Welcome back to school, Algebra 1 students. We are going to get started this week on something you love, and that is graphing. I know you hate it, but you've already learned some of the basic principles. So today we're going to start chapter 11, okay? And so if you don't have your book, pause this and get it so you can look through the things as I go through them. Some of this hopefully is familiar to you. You're applying the same graphing principles that we've learned already. We just have a different parent function. Okay, so what do I mean by that? All right, we're graphing the square root function. So hopefully you can see this. We're looking at y equals the square root of x. All right, now you can make tables to plot these graphs. I'm not asking you to when you do your homework. I will show you what I'm looking for. Okay, y equals the square root of x. Okay, we know that if x is 0, the square root of 0 is 0. Okay, so it starts there at the origin. If x is 1, the square root of 1 is 1. Now, it's important to recognize we are assuming, since the square root of a negative number is undefined, we're going to use positive values for x. In that way, when you look at your graphs today, we're finding the domain and range, meaning what areas are covered in these graphs. So for all the square root graphs, your domain, x has to be greater than or equal to 0. All right, I think I have a better black marker. I just got to find it. So your domain, x is greater than or equal to 0. Okay? So another one you know very well, if I put 4 in here, for the square root of 4, I'm going to get 2. So if x is 4, 1, 2, 3, 4, I'm going to get 2. Okay? So this parent function, the square root graph, looks like this. Okay? It's kind of that kind of a curve. All right? That's what we call the parent function, y equals x squared, and I did it in black. All right? You'll notice all my x values are greater than 0. Okay, so the domain x is greater than or equal to 0. All my y values, no matter what I plug in there for x, non-negative x, okay, y is also going to be greater than or equal to 0. So my range, y is greater than or equal to 0. I don't have anything down here. All right? So what does that mean? Okay? Let's look. That's my parent function, square root of x here. All right, in blue, I have written a couple other problems. Y equals 3 square roots of x. Okay? If you want to think about it, you have that same parent function, square root of x. What did a large number in front of that mean? A large number meant a vertical stretch. Okay? I was making it taller. One good thing to use is, if I look at that number in front of there, my first point is going to be at 1, whatever that number is. So if I'm looking at how to graph that, you know it starts at 0, 0, right? My first point will be if x is 1, y is 3. Okay? If x is 1, square root of 1 is 1 times 3. My first point is 1, 3. Okay, and I'm going to just kind of do a rough thing like that. Okay, again, my domain, x is greater than or equal to 0. My range, all my y values are greater than or equal to 0. Okay, hopefully you remember, if my number in front is a fraction, we call that a vertical shrink. Okay, so again, if I look at this number here, and my first point is at that coordinate right there. 1, 1/3. So 1, 1/3. Okay, this tiny little dot down here. All right, just above my x-axis. And I'm going to go ahead and draw this line. All right. We call this a vertical shrink, right? Skinny or squished. Again, x is greater than or equal to 0. That's my domain. All my y values are positive. Y is greater than or equal to 0. Okay? Hopefully this is familiar to you. Okay? If it's a whole number in front, it's a vertical stretch. If it's a fraction, it's a vertical shrink. You're making it smaller. Okay? So I'm going to erase those, but I'm going to leave that black one there, that black parent function, right? And we're going to do some on this side now with some other concepts of graphing. All right, here's my parent function. All right, what if I have y equals negative 1/2 x? My parent function, I'm going to actually do it this way and think about it like this. My parent function for this one is going to be 1/2 x, okay? So if my parent function is 1/2 the square root of x, all right, then here it was at 0, 0. My parent function is at 1/1/2, okay? So my initial graph kind of looks a little skinnier like that. Now, what happens if it's a negative in front of that? Hopefully you remember, a negative means I flip this function, okay? So instead of, there's my parent function, here's what y equals negative 1/2 square root of x. All right, what's my domain? Again, x is still greater than or equal to 0. Okay, all my x values are still positive. But what happened to my range? Okay, now my range, all my y values are down here. So my range in this case is y is less than or equal to 0. Okay, so parent function, identify the domain and range. All right, well, let's see. Hopefully you remember that. Let's try one in red. Let's do y equals, we'll stick with 1/2 x. Okay, and let's go ahead and say plus 2. Hopefully that you remember this plus 2 after it means I'm going up 2. So I take that same parent function, 1/2 x, right? 1/2. And I move it up 2. Okay? So I'm going here, and I'm going to start here, and then I have that function. Okay, there it is in red. Now what's my domain and range? My domain, x, is still greater than or equal to 0. These are all positive. But what's my range? Y is now, starts at 2. So y is greater than or equal to 2. Well, what if I did, let's do this in, we'll do this in red anyway. Y equals 1/2 square root of x minus 2. Hopefully you remember that. Here's my parent function. That means I'm going down 2. Okay? Now I didn't flip it, so it's not going to go upside down. It still goes like that. Okay? So my domain, x is still greater than or equal to 0. What's my range? What is y? Now, y has to be greater than or equal to negative 2. Okay? Hopefully you can see that. I don't know if I need to, maybe that helps there if I get out of the shadow a little bit. And you can see identifying the domain and range when I have numbers outside of the square root or the radical sign. Okay, well, you should know that's called a radical sign. Now there's one more option, maybe you remember it, but what if I have numbers underneath the radical sign? So I'm going to leave my parent function in black. I'm going to erase these. Okay. Now, let's do red again, just because that shows up pretty well here. Fix our graph, my terrible black marker. All right, so here's my parent function, y equals 1/2 x. And to determine my parent function, I'm really just looking at what's here and what's in front of here. Notice there's just a 1 here, so my parent function for that was the 1, 1 graph, right? But here it's 1, 1/2. So what if I have y equals 1/2 square root of x minus 2? Okay, there's two options. I have 1/2 the square root of x plus 2. Okay, what do those look like? Let's do this. We'll do this in red and blue so it's a little clearer. All right, when we do these, hopefully you remembered before we were talking about numbers within a parentheses. If there's a number under the radical sign, you're going to look at this and figure out what's going to make this 0. Where is it going to hit my axis? Where is it going to intercept? Well, if x is 2, that makes this value 0, 2 minus 2. So that's where I want to put my first place here. So when x is 0, or when x is 2, excuse me, that makes this 0. I'm looking at my intercept, okay? In other words, if this is a negative 2, I'm going to move it 2 to the right. Okay, that same graph, 2 to the right. All right, what is x in this case? What is my domain and my range? In this case, x is greater than or equal to 2, not 0, to 2. And in this case, y is still greater than or equal to 0. Okay, my domain changed. Well, what if it's plus 2 underneath this radical sign? What will make this 0? A negative 2, okay, or moving it to left. So in that case, I move it to left, right? What is my domain? X is now greater than or equal to negative 2. My range, y is greater than or equal to 0 still, okay? Now, you will have some more complicated ones to graph. Let's say it says, and we'll stick with, well, we'll just do square root, okay? Let's go ahead and try one more example. And let's just go back to our initial one. Okay, here we are. All right, close enough. Let's say I'm going to graph something that is, so I'm going to go with 1, 1. Okay, this is y equals square root of x. All right. And you're like, well, Miss Winfrey, our problems are much harder than that in the book. Okay, y equals, let's say, negative square root of x minus 3 plus 4. That looks like fun, right? I'm still using the square root function, okay? Now, the first thing I know is that it flips, okay? So I take that square root function, and now I know I've got it like that. That takes care of that. What does the minus 3 mean? Remember, it means I'm going to move it right 3. So now I'm going to start it here, and it would look like that, okay? Because I have to move it right 3. What does this look like? It has to go up 4. So now it means it's here. And it looks like that. Okay? So, what's my domain? What's x going to be there? Okay? It was over at 3, so x has to be greater than or equal to 3, right? Can't see it here, but there's my 3, right? And what about my range? In this case, y ends up being less than, right, or equal to 4. Okay, it won't be up past that. Okay, so hopefully it gave you a good perspective here. If you have trouble, watch it again. There are other resources you can find. You can certainly look on YouTube, find some other explanation, walk through the examples in your book, see if that helps you. But hopefully you've got those graphing principles down. On your homework, okay, I have asked you to write the parent function, what the parent function would look like, and then in another color, what is this final graph look like? Remember, if you have something that looks like this, the parent function is 2 square roots of x. So your first point should be at 1, 2. That's your parent function, whatever's in front of here. In this case, I just had a 1 here, so my parent function was just this. Okay, so make sure you pay attention to that. Graph the parent function in one color, preferably black or pencil. Get another color and graph what your graph looks like now. You do not have to make a table of values. You can if you need that, if it helps you. What I've shown you here today should be enough for you to get a pretty good go of it. Do not make them all on one graph. I want you to do individual graphs. You can sketch them like I did, preferably graph paper. You should have it. Put them on graph paper, but don't put them on one big graph. I want individual graphs for all of these. Okay, if you have questions, you know I'm here to answer your questions. I have a Google Meet time just for your class because you are very special, from 2 to 3 on Monday and Wednesday. So if you get into your homework and you get stuck, if you just can't figure it out where to start, if you're not sure about your parent function, whatever, you don't understand my directions, come to my Google Meet. That's what I'm there for. I mean, I'm just sitting there grading papers and, drinking my coffee as always. So come ask me questions. I'm happy to help you. I'd rather you get help than you move forward and get stuck on these things later. Okay? So again, my Google Meet, you can come from 2 to 3, Monday and Wednesdays, since you have Fridays off now. That should be it. And I look forward to seeing you if you need some help. Most of you, a really great job on your projects. That was awesome, and those grades are in. So, super job there. Have a great day.